In this video, I'm going to teach you how to solve a system of linear equations by what is called the substitution method. Now, I have a couple steps for you that I'll be doing for every single problem, and I want to tell you what those steps are before I start. First, number one, you have to take one equation and you need to solve for one of the variables. Either x or y, doesn't matter. Then, after you've solved for that one variable, you're going to sub the expression into the other equation. And then what you're going to do is solve for that variable, variable, and then number 4, substitute the value that you just found into either equation. So I kind of used up all the space there at the top. And so I want to show you what that looks like, and I'm going to do 6 examples with you, okay? So stay tuned here. Hopefully you got a little patience, and I'll be as descriptive as possible when we're solving here. So I noticed that both of my equations happen to already be solved for one of the variables. So the first step here is done. But what I need to do is take the expression that it's equal to, meaning the 2x plus 7, and I'm going to sub this expression into the other equation. So if this is what y equals, if y equals that stuff, then I'm going to put that stuff into the y of the other equation. All right, so it's going to look like this. In for this y, I'm going to plug what y is equal to. So I'm going to set 2x plus 7 equal to this x minus 1. So I've put this expression into the y of the other function because that's what y was equal to. Now what I'm going to do is solve for the variable that I see. I see x is here. I'm going to solve for the variable of x. So I'm going to subtract 1x, and I am going to have 2x minus x, which is 1x, plus 7 equals negative 1. So I'm solving for my x. Subtract 7 to the other side, and I get x is equal to negative 8. Now I've done step 3, which is solve for the variable. I got negative 8. Now in this case, what I'm going to do is substitute the value that I just found into either of the original equations that you have. It doesn't matter which one you pick. I'll show you for this one time only that you're going to get the same answer, but you really only need to pick one equation. But here today, just this one, I'm going to show you it'll work the same for both. Okay, so let's say you pick equation 1, and you substitute here, and for your x, negative 8. So y equals now my 2x plus 7. If I sub in for my x, the value that I just found, which was negative 8, I will have y equals 2 times negative 8 plus the 7, which is 2 times negative 8 is negative 16 plus 7, which is going to be a negative 9. So that's equation 1. Now I have found my y value. So here's my x and here's my y. So my solution to my system would be an x value of negative 8, a y value of negative 9, and I'll show you you'll get the same thing if you had picked instead the second equation. I'm not going to do this for all of them, just for this one. So let's say if you had picked equation 2 and you say y equals your x minus 1, and again you plug that x value that you just found back in, y equals negative 8 minus 1, and negative 8 minus 1 is negative 9, which gets you the same answer that I had plugged in for the first equation. And so the last step, it doesn't matter which equation you pick, plug it back into either. Okay, now we're going to repeat this process. We're going to solve these other methods by substitution. So it's just a little different way than solving by graphing, especially when you get pretty big numbers. Normally we don't want to graph something that has like 55 in it, and so that's where substitution comes in handy. So again, start with solving for one variable, and luckily this one already is. So I'm going to sub this expression into the y of the other equation. And when I do that, it's going to look like this. So I'm going to plug 3x into the y. So my x plus instead 3x will equal negative 32. And 1x plus 3x's is a total of 4x's that equal negative 32. And if I divide by that coefficient of 4, my solution for x, the point of intersection for these two lines, is going to be negative 8. So now I have half of my answer here, because my answer is a point, and a point is an x comma y, so I know it's negative 8 comma something. Let's find what that something's going to be. So now that I know the value, I solved for the variable x, sub that value into, again, either original equation. So I'm going to pick the top equation, y equal to 3x. And now this is the second part of substitution. It's actually substitution again. All right, so if this negative 8 gets plugged in for x, I will find the value for y. So if I plug in negative 8, I get my y value, which is negative 24. And so that is my solution, the point, negative 8, negative 24. All right, let's keep going here. Now, these equations are not like the ones that we started with. None of the variables are solved for. And so then what you want to do is look for, here I'll add this little star here if you can. Look for a coefficient of 1. And that's going to be important here, and I'll show you why. I only have one letter that has a coefficient of 1, and it is this y value right here. All the others have a coefficient, and the reason why we want a 1 is because let's say we were solving for x. In the end, if I have to divide by 2, I might get some fractions because I'm dividing by a coefficient of 2 to solve for 1x. And so what you want to do is look for a coefficient of 1. It's going to make it a little easier. So here I'm going to solve for y, and I'm going to do that by adding this 2x over to the right side. So actually, I don't really want to circle that because I'm going to be circling other things. So I'm just going to write plus 2x plus 2x. So my y will equal instead a 2x that I added to the right minus the 3. Now, the second equation, I've solved for y, and I got an expression that I'm going to solve in, I'm going to put this expression into the y of the other equation. So now, this top equation with my substitution will look like this. 3 times the y, which I'm going to put this stuff in here, 2x minus 3, plus 4x is equal to 14. So that's my first equation with my substitution here. Now let's solve for our x, because we got only x's now. 3 times 2 is 6x. 3 times negative 3 is minus 9. Plus 4x equal to 14. Now I have a like terms here that I'm going to combine together. My x's here, I have a total of 10 x's. Minus 9 is equal to the 14. I'm going to add 9 over, and I have 10 x's equal, let's see here, 14 plus 9 is 23, and I'm going to divide by 10. X is equal to, I'm going to get 2.3. Oops. I almost wrote a 6 by accident. 3. All right, so now I've got my value for x. I'm going to plug 2.3 back into either original equation. I'm going to get my solution here kind of started because I know 2.3. You know, sometimes you don't get a whole number. That happens. All right, so I'm going to pick the top equation. I mean, it really doesn't matter. 3y plus 4 times 2.3. Let's see here, then equals 14. Okay, so I'm just kind of off to the side here. 3y plus, well now I need a calculator, so let me grab that. 4 times 2.3 is equal to 9.2. So 9.2 equals 14. Now I'm going to subtract that 9.2 over. 14 minus 9.2. is equal to 4.8. If 3y is equal to 4.8, let's divide by 3, and I get an answer of 1.6. There we go. Now, if you needed to put those in fraction form, you know, if your teacher asked, you could totally do that. But I'm going to leave mine in decimal form. All right. Since this video's gotten pretty long, I'm going to go ahead and pause this video here and start a new one for our last 3 problems for substitution.